We live in an age where technology defines everything. The planet we call home, Earth, will not be habitable forever. With the depletion of the ozone layer, the issue is not whether, but when the world will end. If the human species is to survive, we will have to pack our possessions and relocate to another planet. However, as we all know, space is enormous, and the closest planet to us is Mercury, which is around 57 million miles away from Earth at its closest point in orbit. So no matter where we go in space, we have to go fast. And how fast are we talking? Faster than light or near light speed. This new space age has given humans a new opportunity to explore its available technology and numerous resources. NASA, in conjunction with many space companies, such as SpaceX, Blue Origin, Boeing is frequently working to give humanity a chance and future in space. Will NASA's near-light-speed engine, which defies the rules of physics, actually work? Is NASA finally on the verge of developing a light-speed engine that can outperform SpaceX's Raptor engine in terms of speed and capability? What is the operation of NASA's new speed-light engine? We're sure you'd like to know the answers to these questions. Stay tuned and keep an eye out for the answers to these questions. The EM drive is a spaceship propulsion idea for a radio frequency RF resonant cavity thruster. It is thought to create thrust by reflecting microwaves within this device. This is a violation of the law of momentum as well as other physics principles. The EM drive, sometimes known as the impossible, was initially proposed by Roger Sawyer in 2001. Although there was no official design of this device, none of those who claim to have invented it have made any explanation of how it could operate as a thruster, making it difficult to tell if a particular object is such a material. However, several prototypes have been built and tested based on their public description. The Apple at NASA reported a relatively small thrust from one of its tests conducted. It has not been repeated ever since. Although an investigation into the previous test showed that the thrust was due to a measurement error caused by interactions with the Earth's magnetic field. Now let's talk about the different kinds of thrusters and what makes an EM drive different. Rocket engines operate by expelling propellant, which acts as a reaction mass and also produces thrust. In the 1960s, ion thrusters that convert propellants to ions accelerated and ejected them through electric potentials. Plasma thrusters that convert propellants to plasma ions accelerate and eject them as plasma currents. A device that does not expel propellant in order to produce a reactive force, providing thrust while being closed with no external reaction, will be a non-reactive drive. Such a drive goes against physics, an example of the EM drive. On September 20th, 2017, the Chinese Space Agency released a video back then showing a supposed functional EM drive. A reporter, Dom Galeon, wrote, "Have the Chinese finally made the impossible happen? Let's not be quick to jump to conclusions, though at least not as fast as China did. The need for the EM drive is understandable, because if it was actually possible, then it would only mean one thing. It will make spaceflight cheaper and travel at light speed, which is faster. It's every space company's dream. Isn't that amazing? Now, here's the catch. The functionality behind the EM drive goes against physics. It goes against Newton's third law of motion. For every action, there is an equal and opposite reaction. So according to physics, it is impossible for thrusters to generate motion in space without propellant. Well, some of you might be thinking, what's the essence of physics if it can't solve this? Well, the good news is that the EM drive might be explainable and attainable by another extended form of physics not yet achieved by humans and scholars. So, who knows? Your kid might just be the physicist who does that. An advanced propulsion system expert, Bryce Casanetti, said, "Action and reaction is a direct result of the conservation of momentum." People usually confuse the warp drive and the EM drive. These are two different drives. The warp drive, which only remains possible in the world of science fiction, is a faster-than-light form of travel, FTL. It breaks the speed of light by warping the fabric of space and time. This has been termed impossible by many scientists, and even considering Einstein's theory of relativity, said NASA. The co-author of the study, Martin Tamjar, a physicist at TU Dresden, told German outlet Glawai, "When power flows into the EM drive, the engine warms up. This also makes the fastening elements on the scale warp. making the scale move to a new 0 point. Our measurements prove all EM drive claims by at least 3 orders of magnitude. It's really a pity, because a fuelless thruster would be a blessing to human exploration and ramifications. The EM drive has been a small but crucial part of DARPA, an R&D wing of the United States of Defense. DARPA investment in the project ran through May 2021, so the funding for this precious project everyone had so much hope had limited time left. To clarify all we have said so far, the EM drive, warp drive, is just impossible yet, so let's talk about NASA's new engine. A mission was initiated by NASA recently, which is intended to launch in August 2022. The spacecraft will be traveling about 1.5 billion miles, which will take them 3.5 years to get to a particular metal-rich asteroid they called Psyche. They will be doing this in partnership with SpaceX. Once in orbit, the team on the mission will use the payload of science instruments to investigate what the unique target can reveal about the formation of the rocky planet in comparison to Earth. The spacecraft will rely on the rocket engine powering the Falcon 9 to blast off from the launch pad into space. Once the Psyche separates from the launch vehicle, it will rely on solar electric propulsion. Solar electric propulsion starts with a big number of solar arrays that convert sunlight into electricity. This becomes a power source for the spacecraft thrusters. As for the propellants, it'll carry a tank full of xenon. The 4 spacecraft thrusters will make use of electromagnetic fields, EM fields, to accelerate and discharge charged atoms or ions of that xenon. As the ions or atoms are discharged, it creates thrust that gently propels the spacecraft through space, emitting blue lights of ionized xenon. It'll eventually accelerate to a speed of 200,000 miles per hour. Because of the efficiency of the propulsion thrusters, they can operate non-stop for years. Maxar's Psyche program manager, Stephen Scott, said, "Solar electric propulsion technology delivers the right mix of cost savings, efficiency, and power, and could play an important role in supporting future science to Mars and beyond." During a government hearing on October 20th, 2021, experts from NASA and the aerospace company discussed how the U.S. stacks up against other nations when it comes to developing new nuclear propulsion technology, and according to NASA, the government needs to move quickly if it wants to keep up. NASA experts say the government needs to invest in nuclear spacecraft in order to be able to compete with other nations like China. All this took place before the U.S. House of Representatives Science, Space, and Technology Committee. Strategic competitors like Russia, China, are aggressively investing in a large range of space technologies, nuclear power, and propulsions. NASA has recently enlightened and discussed how nuclear propulsion technology could allow the agency to send humans to Mars, and at a fast speed, rather than using traditional chemical spacecraft. The nuclear electric propulsion system uses propellant more efficiently than the traditional chemical rockets do, but provides a low amount of thrust. NASA also added, the nuclear electric propulsion system gives the spacecraft more speed for an extended period of time and can achieve a Mars mission for a fraction of the propellant of the high-thrust system. According to what NASA's experts say, if NASA wants to get to Mars soon, then time is of the essence. U.S. Representative Don Beyer, DVA, who is the chairperson of the committee, said, "If the United States is serious about leading a human mission to Mars, then we have no time to lose." This clearly demonstrates that while NASA may not have obtained the precise EM drive, they do have the option of using something similar, known as the nuclear electric propulsion, if they are desperate to reach Mars in time. They may also utilize the sluggish but dependable solar electric propulsion, which is also ideal. So, do you think the U.S. government will ignore NASA's critical suggestion or approve it in order to increase their chances of traveling to Mars quickly? Do you believe the EM drive and warp drive are still feasible? Will NASA's near-light speed engine function properly? Tell us what you think and how you feel about all of this in the comments section below.